9.6 is on probability, and today we're going to calculate the geometric probability of an event occurring. So, probability of an event is measured of the likelihood that the event will occur. And it is always going to be a number between 0 and 1 inclusive, and can be expressed as a fraction, decimal, or a percent. And we are going to be using fractions in this chapter. And the probability of event A is written as the probability of A. So this right here, you're going to see a lot where you're going to have something inside of parentheses next to a P, and that means probability of event A. And we can replace A with anything. It could be the probability it rains, the probability it's the color blue, anything like that. So when it's closer to 0, that means it's impossible or unlikely to occur. If it's 1 or close to 1, it's likely or certain to occur. And if it's about 50% or in the middle, 0.5, it's equally likely to occur or not occur. And we are going to be working with the geometric probability. And this is a ratio that involves a geometric measure such as length or area. So we're going to be putting either a length over another length or an area over an area. And we're going to go over some examples of what that will look like. Looking at example 1, we're going to find the probability that a point chosen at random on segment PQ is on RS. So when you're writing the probability of an event, that is going to be equal to the number or value of the desired event over the value of all possible events. So what that looks like in this example. For this one, we're finding the probability that a point chosen at random is on PQ. So on segment PQ. So our desired event that we want is that it lands on PQ. So we're going to look, I read that wrong. Sorry. We're trying to find that a point chosen at random on PQ is on RS. That's what we're looking for. Sorry about that. So we're trying to find the probability it lands on RS. So we're going to highlight from R to S, and we need to figure out what that length is. And we're going to count the spots just like we would for if we were counting on a game board. So if we start at R, we would go 1, 2, 3, 4, 5, 6. So the desired outcome is 6 total points that we could have. Now, we are going to look at the total possible outcomes, or the value of all possible events. And that is that it just lands on PQ. So we're going to count the length of PQ as well. So when we do that, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a total of 10 spots that PQ can land on. And when you find the probability, you are going to want to simplify it as a fraction. So we're going to divide these by the greatest common factor of 2, and we're going to get 3 over 5. So the probability that we land on RS is 3/5. Okay. Our next example. And this one is a word problem, and this is an important one to review because there will be one similar to this on the test. And this one says, a monorail runs every 12 minutes. The ride from the station near your home to the station near your work takes about 9 minutes. One morning, you arrive at the station near your home at 8:46. You want to get to the station near your work by 8:58. What is the probability you will get there by 8:58? Okay, so let's figure out what is the longest amount of time that we can wait. We know that we got to the station. Let's start by making a timeline. At 8:46. So that's when we got to the station near our house. And we want to get to work you want to get to the station near your work by 8:58. So over here, we're going to put 8:58. And we know it takes a total of 9 minutes for the train to get from the station by your house to the station at your job. So we want to figure out the longest amount of time we can wait before we have to be on a train to get to work. So we're going to figure out what is 9 minutes before the time we want to be there. So 9 minutes before 8:58 is going to be 8:49. And that's 9 minutes before. So this length here we know is 9 minutes. So that's the latest amount of time that we can wait. If we're not gone by 8:49, we're not going to get there at the time we want. And we drew our number line model. So now we're going to find the probability that we get to work on time. So we're going to find the probability to arrive by 8:58 equals. So the desired outcome is that we leave between 8:46 and 8:49. So the total number of minutes between 8:46 and 8:49 would be 3 minutes because we would count 8:46, 8:47, that would be 1 minute, 8:48 would be 2 minutes, and 8:49 would be 3 minutes. 1, 2, 3. So we would have 3 minutes over, and we don't know when the train is going to come, so it could come between any of this time period. So we knew this section here was 3 minutes. We know the second section was 9 minutes, so it could be a total of 12 minutes between when the train could come. And then we can simplify. The common factor between 3 and 12 is 3, and we would get 1/4. So if you get there at that time, there's only a 1/4 of a chance that you are going to get to work on time. There we go. So for this one, again, following these steps and completing them is going to help you get to your answer. So you're going to want to draw a number line and label what you know, figure out what the longest amount of time is and the shortest amount of time, and then find your probability. All right, our next example. And this one, if you want to get the practice, pause the video and find your answers, and then click play to see if you did them correctly. So for our extra practice, we're going to find the probability that a point chosen at random on PQ, so that is all of our possible outcomes for P all the way to Q, is on the given segment. And we're going to express our answer as a fraction. So the total distance between P and Q would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means the bottom number of all of our fractions are going to be 10 because that is the total outcomes possible. Now we just need to figure out what the top numbers are going to be. So the first one we're looking at is RT. So the distance from R to T is 1. So 1/10 is the probability we land on RT. Then we have TS, and from T to S it's 1, 2, 3, 4, 5. So the probability that we land on TS is 1/2. And then we have PT. So from P to T, we would have 1, 2, 3, 4. So the probability that we land on that would be 2/5. And our last one, we have RQ. So we go all the way from R, 1, 2, 3, 4, 5, 6, 7. And so 7/10 would be our answer for that one. So if you didn't get any of those correct, make sure you get those fixed before moving on to the next section. All right. And our last example, so far we have been doing probability of lengths over lengths, and that was our geometric probability for length. Now we're going to do a geometric probability for area. And when you're finding the probability of area, you are going to want, again, on top, the region you want the point to be selected from, or the area you want that to be from, and then the total area on the bottom. So when you're doing probability of area, you want the desired area on top, and then the total possible area on the bottom. And that's how we're going to find the probability for this part. So example 3, looks like I forgot a T there. The diameter of the target shown is 80 centimeters. So that means for this circle, all the way across is 80 centimeters. The diagram of the red circle in the center on the target is 16 centimeters. So that means in the middle we have a red circle, and that is 16 going across. An arrow is shot and hits the target. If the arrow is equally likely to land on any point on the target, what is the probability that it lands in the red circle? So for this, we want it to land in the red, and the total possible outcome is anything inside of the black circle. And on the top, they did give us the area formula for a circle. So we're looking for the probability that it lands in the red target. So when we find this probability, we're going to have the area of the red circle. And then on the bottom, we're going to have area of the outside circle, or the black circle. So now we can calculate those values. So the probability that it lands on the red target, and the area of a circle is pi r squared. And remember, the r is half of the diameter. So our radius for the red one is going to be 8. So our area for this is going to be pi 8 squared all over, and the area of the black circle, the radius of that would be 40, would be pi 40 squared. And when you're simplifying this, you'll notice there's a pi on the top and the bottom, so those simplify together. And 8 times 8 would be 64 all over, and 40 squared would be 1600. And we just need to simplify this. So we have 64 over 1600. Grab here. And remember, you can use the calculator to simplify your fractions. So the likelihood of us hitting that red target would be 1/25, or 1 out of 25. That would be our final answer. So if you have any questions on this, please let me know, and you should have everything you need to complete the homework.